I may slip every once in a while and talk about the framework, but it is the same intellectual property we're talking about here today. If you have any questions at any time, please let us know. Otherwise, I'm just going to go through it. I've got a few slides here to talk about the accelerator in general, and then we're going to follow that up with a live demonstration. So the benefits of the ETL Accelerator, like I said, we've been using it for a few years. It helps us to provide a consistent methodology for extracting, transforming, and loading data from multiple data sources into either data warehouse or other target system. And it leverages SQL Server integration services from Microsoft. Some of the other things that we built into this tool is that it really encourages portability, reusability, auditing, and error handling. We find that SQL Server integration services out of the box provides a lot of tools and so on for building out the ETL process, but there are key components that we often need in an enterprise deployment of SQL Server integration services, and we felt like a tool like this would help to simplify some of those tasks and remove some of the overhead from ETL development. So. As you're going to see through the demonstration, it's quite a time saver, on the ETL development process, typically by about 40%. And we've also used it to train some of our clients as well on SQL Server integration services. So when they see, some of the accelerator components in action, it kind of gets them up and running quicker with the platform. As I said, we've been doing this for a number of years. It's a value-added feature for our Neudesic clients. We don't charge anything for the accelerator, but allows us to come in very quickly where we need to do ETL work and hit the ground running, and really allows us to get going with some enterprise class development on the ETL front. So an accelerator like this is just an approach to ETL development. It's not a hard and fast rule. It doesn't mean, oh, I have to build out my ETL process the way that the accelerator says I need to. It's just a starting point. It's just code to get you started with your project, and but it's just a guide. And it's what we often do is we start with the accelerator on a new project. We sit down with the IT team that we may be working with on the project and take a look at the business requirements for the ETL process, and then we sit down and we actually customize the accelerator for each customer and each project situation. But it allows us to get about 80–90% of the development out of the way up front, and then we just tune it from there. And then once we get the accelerator where we want it for a particular project, then we go ahead and start the development process. The accelerator is something that we improve over time. We're making enhancements all the time. We're building in new features. As we go project to project, we continually add to the code base, simplifying things where we can, automating and streamlining things. So it's something that we improve over time. We do make those updates available to our current clients so that they can integrate new functionality. And so it's not a stagnant piece of code for us. It's actually a living piece of intellectual property that we're always improving. Just a little background on ETL principles and best practices, just so that we're all on the same page with an ETL process. One of the most important things is to take time to profile your data, really understand the data that you're bringing into the data warehouse or whatever target environment that you're working with. It's really important to understand data anomalies and where the data may need to be transformed, for the target environment. Really need to understand how data will be used by business folks, especially in a data warehousing BI environment, and discuss the capabilities and the deficiencies of the data within users. As most of us know, an ETL tool is not meant to cover up all the mistakes and all the data quality issues in the source system, and that we still believe that correcting the data in the source system is always the best choice, and we should do that whenever possible. By doing in that fashion, when building out a data warehouse, We don't want to get into a lot of issues. This is the data in the source system, this is the data in a data warehouse, and there being a difference between the two when we might have been able to correct some of that information in the source. Obviously, we don't want to spend all our time cleaning up data, so it's good to establish good data governance procedures and standards to improve the quality of incoming data. It takes a lot of effort to fix up data, as most of us know, and anytime we can improve the data quality on the back end, that's always advantageous. Define business rules for transforming business data and provide some documentation to end users as to how we're transforming their data, what edits we're applying, if we're changing values, which values we're changing and why. So that's all part of the ETL process in transforming business data. I also want to understand something about data availability, security and retention requirements. So, during the analysis process, on an ETL project, just understanding what information is available in the source, how the data needs to be secured in the target system, and understanding, the history and the retention requirements for the data that we're loading. And then finally, provide documentation for the ETL process. A number of places we go and we look at, ETL development that's been done. They may have started some source to target mappings, but they never keep them up to date, and they become old fossils before too long. So it's important that we actually provide some documentation that shows how data in the source system will be extracted, transformed, and loaded into a target environment, and then we provide some documentation around that process. So just good practice. We see out there a lot of folks aren't following that all the time, but it's definitely a good process to follow. It's kind of an architecture slide on the ETL process and the ETL Accelerator. We recognize that there's a number of data sources coming into a staging environment, and we believe that all data should be staged, even data coming from spreadsheets and so on, because it's far easier to stage spreadsheet and flat file data into a SQL Server table in its original form and query and analyze that staged data than it is to pull staging data directly into a data warehouse environment, for example. So, our best practices for us on ETL architecture is stage all data, no matter where it's coming from, no matter how simple it might be. It's just good to run all the data through the same process. So we bring data into staging as it shows on this slide. We may move it to a data warehouse or another target environment, and then we often use the ETL process to build out any cubes and SQL Server analysis services. The framework, the Accelerator recognizes that that its metadata for ETL configuration can be stored anywhere. It could be stored in a separate ETL database. It could be stored in a staging database, as I'm showing today. And that we want to be able to do some reporting on the ETL process. We want to know what errors we had, what packages ran, what kinds of errors they generated, and then we want to know something about the process as well. So, the Accelerator just brings a number of pieces together, auditing, error handling, and incremental loading capabilities as well. Just an overview of the Accelerator and some of the features. We take full advantage of package configuration. So many of you may be familiar that within SSIS you can actually create configurations for your packages so that you can set a number of variables at runtime. So we make full use of that. You probably know that you can store configuration information in environment variables and SQL Server or parent package variables. Our strategy on this is we use two environment variables to actually find the location of where all the rest of the configuration information is stored, and then we use a SQL Server table to provide all the configuration information to the ETL environment, and I'll be showing that here in a couple minutes. From an auditing standpoint, touched on it briefly already, but we want to audit package execution. We want to know which packages ran when. We want to know how long they've taken, whether there were any errors or not. In terms of the tables that are being loaded, we want to know things like how many records were in the destination table before we started, how many records do we insert, how many records do we update, how many records are in the final table after we're done. We want to know how many records we extracted from the staging environment, and know how long the process took. Another thing we want to do is we want to track inserts and updates, and so we have a mechanism for keeping track of every package that's been run, when it ran, and we tie an audit key to it, and we basically track every record that's inserted or updated in the target environment. So this is great from a SOC standpoint, or just from a pure data standpoint. When we have an ETL process that's gone wrong, we know what instance of that process ran, we know which records it touched, and we have the opportunity to back out data or go back and change data later. So very helpful. From a load standpoint, we know that when loading data, we're often doing initial loads, and then we're following those up with incremental loads. And our thought on this process is it's the same package, the same ETL package in both instances, but we're using different criteria, a different scope of data, if you will, that's going to be loaded. So I'm going to show you a strategy in one of the packages here where we're actually using a single package to do both full and incremental loads, and we're controlling whether a full or incremental load is done with a lookup table. In terms of staging and error handling, we've got a strategy for building out staging tables and error handling tables, and we actually have some scripts that generate those tables automatically for us, especially if it comes from a SQL Server source system. So I'm going to show you a little bit on that. Probably one of the biggest things out there for the accelerator are these package templates that we've built. We have templates for master packages, dimension packages, fact packages, and staging packages. We're going to be getting into these templates in just a minute, and you'll see that it's a huge value add when you sit down and do ETL development and you've got a template to start out with. And then finally, we want to provide some reporting on the ETL process. So put together a number of just stock standard reports that allow me to go in and look at package execution, tables we've loaded, and so on. So for the ETL Accelerator, we've created a small data model. The data model facilitates the storage of results out of the ETL process and provides configuration information of the ETL process. So I can just give you an overview of this data model. It's fairly simple. On the upper left-hand corner here, we have a ETL configuration table, which is pretty much the stock table that SSIS will generate for you when you decide to store your configurations in a SQL Server table. We've just given a name to it, and it's one of our metadata tables. Here in the center, we have a table called Audit Package Execution. The job of this table is to keep track of all the packages that have been executed, keeps track of the name of the package, some GUIDs around the package, the version of the package, the execution start time, the stop time, whether the process was successful for this package load, and then the parent package execution key points back to a parent package. So the strategy we use is a coordinating or master package calling child packages, and so we're keeping track of both the master package's execution and the child package execution. Down here we have another table called Audit Table Processing, and the role of this table in the accelerator is to keep track of the tables that we're loading. We're typically loading one destination table with each package. That's the strategy that we've chosen, and it's worked well for us for a number of years. The reason that we load a single table with a package is it allows us to keep our packages very modular, not try to do too much in any individual package. As you know, we can use multiple data flows and load multiple tables in each package if we choose, but instead we've chosen a modular approach and just loading single tables, which works out really well for us. So this audit table process, this table down here, audit table processing, keeps track of the package that caused this data load. We keep track of the extract row count, initial count in the target table, insert records, update records, insert errors, update errors, and what the final count is and whether the process was successful or not. We've actually expanded this table quite significantly, especially when handling type 2 dimensions where we want to keep track of SED2 updates, SED2 inserts, and so on. So what you're seeing today is kind of it's a simplified version for demonstration purposes, but we've certainly taken the accelerator much far beyond what you're actually seeing here. But gives you an idea of some of the things that we're doing. Up here in the upper right-hand corner, we have an audit table. The job of this table is to generate just a unique key called the audit key, and we'll use this on all the tables where we're doing inserts and updates. Over here in the lower left-hand corner, I have a table called Package Load Strategy. This table keeps track of all my ETL packages and whether I want them incrementally loaded or fully loaded, and if I'm incrementally loading them, what's the load date that I'm going to load from. So it's this table that allows the ETL developer to flip an indicator off and on as to whether that person wants a full load on the table or an incremental load. And so this table is updated through the ETL process to reset the next load date after a successful load. Let's sit on the model. Here's just an example of what a configuration looks like in the ETL Accelerator. You can see some of the things that we've built into it, but certainly on a typical project, this is going to expand well beyond what we've got here. You can see I've called off a file path for any access databases that I may load. This allows me to, on the fly, change the location of those databases if I want to load them from somewhere else. Keeping track of a from email address for all all SendMail tasks. So I want to know who's going to send the email when there's a success or a failure in the ETL process. I also have an email to line that actually keeps track of multiple email addresses who need to receive notification from the ETL process. So you can add the addresses separated by semicolons. Just a few others here. I won't go through all of them. We've got an Excel file path where all my Excel spreadsheets might be located, flat file path where all my flat files are located, an indicator whether the last ETL process was successful, where my OLAP server sits, where my packages sit, out on disk, if I'm using packages that are stored in the file system as opposed to SQL Server. Here's my SMTP server for all SendMail tasks. And then these databases down here, they're kind of named generically for this demo, but basically every source or target database connection we try to maintain in the ETL configuration table. This allows us, if any of the databases move that we're loading or loading from, we can easily change through this one table, change the location of those databases. And so when you've got 50 ETL packages out there and someone says, hey, we're going to move our test environment from this server to that server, I don't want to go in and touch every single package that I've written. So what you see here is really promoting portability of the ETL environment right down to where these packages are stored, as I mentioned here. So using this information, I can easily move all ETL packages to different servers. I can move this ETL configuration table with those packages. I just change some of the values here in this table, and then I'm able to run in a completely new environment. And because I'm using some environment variables to indicate where the location of this table is, I'm fully neutral and independent from the server on which the ETL process is running. Here's an example of error handling with the ETL Accelerator. So we've got a forecast table. We had a forecast table from the source, and so this is some of the columns that they had listed, exact data types, exact nullability. And then we have a script that basically generates this table, and we put a staging ID on all of our staging tables as an identity column that gives us a reference point back to a particular staging record if a problem occurs. On the right-hand side here, we actually have an associated error table known as the naming convention, stage forecast error. This is also a generated table that we use to keep track of any errors that come out of the ETL process. So in this table, I have some foreign keys back to the package execution table, the audit table processing table. We keep track of where what package task was involved, an error column name if we can get it, maybe some error information, some comments, and then finally a staging ID that relates it back to this staging forecast table. So this is kind of on the surface, this is our error handling process. We're actually using this extensively to report warnings and other kinds of things. If we have problems in lookup tasks and so on in the ETL process, we'll often write records to this table and indicate, you know, maybe a key column that we were trying to do a lookup on. And so we've actually gotten fairly sophisticated on some recent projects in terms of capturing information in this error table and then reporting that back. Here's an auditing example. So we take our typical dimensional model in a data warehouse, and you can see I have a fact table here in the center and a number of dimension tables around the outside. We put some standard metadata in every single table, and other than the dim date table in this example, we have a created date, a modified date, an insert audit key, and an update audit key. The created date is just the system date, you know, the date that we actually loaded this record, so it's just for our own internal use. Modified date is the date that the record was modified, if it was. The insert audit key is the audit key tied to the package that was responsible for the insert in this table, and likewise the update audit key is the audit key tied to the package that actually did the update process on this table. So by putting these standard columns on every single table in your target environment, we're able to then log it, update that information. And then we're able to, if we have a problem with the ETL process, it's pretty easy for us to go query a table and figure out, okay, which records did we touch, which ones did we insert, which ones did we update. This is an example of a package template for a master package. This is the control flow. I'm just going to glance over this a little bit. We'll get into a little bit more detail in the demo. Basically, the master package is the coordinating package executing dimension and fact packages in a data warehouse environment. And so we've got a task up top that basically initializes the audit process for this package. We've got an indicator here being set to true. We go ahead and execute our child packages. We check to see if the process was successful or not. And then we go ahead and close out our audit on the package. And then we send a mail on success or failure. So pretty much a simple flow of a process, just a starter process. You may want to implement a different process on your project, but all of this has been pre-built in the accelerator for use. Moving on to the next slide. We've got a control flow for a dimension package. So you can see there's quite a bit going on in here, and I can go through all of them in excruciating detail. But basically, all these components come in with the accelerator. We check data connections up front, and we fail the package if we don't make all our connections. We do some package initialization, some table initialization here. We go ahead and get the audit key for the process. In this example, we're actually loading the staging tables, and we're actually loading the dimension table all in one package. We have been on several projects here recently within the last year where the customer wanted to split up the staging load from the dimension or fact loads, and so we've built out a number of staging packages that all they do is load staging tables. So it's very easy with the accelerator to break the template into two and maybe do a slightly different process depending on the needs for your project. But this one does a load and staging. Then it starts checking initial counts on the target table. It goes through a dimension load process. I'll show the data flow here in a second. Looks for success, updates incremental load information if it needs to. If the process is unsuccessful, we go ahead and indicate that it was unsuccessful, and then we kind of do a failure path this way. And then in this design in the ETL Accelerator, we're actually denying failures in the data flow, at least non-severe failures, or potentially non-severe failures, and we're keeping track of the error counts recorded in the data flow, and then based on that we may go ahead and fail the package anyway, or we may just go ahead and complete the package, in which case we'll get a final count, we'll update the audit, we'll update the audit table and the audit package. So as you can see, there's quite a bit going on here that you don't need to code, and very few of these different components would you even need to touch even on a new package. Moving on, here's the data flow for dimensions. So for simplicity, I'm not showing the source to staging process. I'm just showing the staging to a data warehouse process in this example. So we've got our stage data coming in. We keep track of an extract count. We do some data conversion if necessary. We'll add some metadata columns. We'll do a lookup on the existing dimension record. If we don't find it, we'll go ahead and through an insert process and start inserting into the dimension. If we get any failures, we add some insert error metadata, some counts, and then write out an error record into the staging error table. And then on an existing record, we go through the SED wizard, doing some update counts, doing an update on the table, some error metadata around that, error counts, and then finally an update or insert into the same error table based on an update process. Moving along, we've got a control flow on fact table loads, so it's very, very similar to the dimension loads. I won't need to really go through it. You'll find that in some cases, we're disabling constraints, enabling constraints to get load performance on our large fact tables. We're doing incremental loads typically, and that's kind of how the control flow looks. On the data flow, very similar process to what we saw in the dimension, same kind of process, loading a fact table, and then loading an error table. This is an example of the documentation, just a simple example of documentation we provide on source to target mapping. We actually have scripts that we run against the source systems that actually go through sysobjects and pull out all the metadata. And so we're able to copy and paste all the information in this blue section for staging. We go ahead and number these. I probably should have a real example in here for you so you can see a little better. But we go ahead and number this column by 5s or 10s in case we have some changes in the staging environment. Then we go ahead and list out all the target columns. And then we basically in this right-hand column we refer to a number that's found in the left-hand column, and that's how we show how one column maps to another. If multiple columns will map into a single column or vice versa, we'll have a number of references here in the mapping section. And then off to the far right-hand side, we'll put any transformation logic that's required. So we're going to jump into the demonstration. Go ahead and share my desktop. Can everybody see this okay? Okay, sounds good. Just to take a quick look here at our simple example, we've got this these MFC databases here. We've got a source database simulating a source environment. We've got a staging database simulating a staging area. You can see here in the staging environment, we've got some of those audit tables we were just looking at, ETL configuration table. And then we've got our staging tables listed here. These are all generated tables based on some of the scripts that we have. And then over here we have our target database, which is MFC, and we're basically loading up a number of dimension fact tables. So just a quick peek here, you'll see the ETL configuration table is loaded with all the information we need for our particular project. You'll see that there's another table here I'll just show you. It's called package load strategy. You'll see I've got each package name listed here and whether I'm doing an incremental load or not. So in this case, for my fact sales package, I'm going to do an incremental load, and I'm going to load it from January 1st, 2008. That's how it's set. If I set this to 0, I set it to false, it'll ignore the state completely, and the SQL that loads the staging environment will just bypass and just load the entire contents from the source database. We jump over to our solution now. I'm going to, in just a few minutes, I'm going to build a package from scratch. I should be able to do it in about 5 minutes. So you can see I've got a project ready to go here. I've got a number of dimension fact packages already created. I'm going to go ahead and create a new one. So I'm going to add a new item. You'll notice that I've got some of these are all the accelerator packages. I've copied. There's a place out on your on the drive, it's down a long path under Visual Studio 9.0 where you can actually copy these templates and make them readily available. And so you can see I've got here one here for a dimension package, one for fact package, and one for master package. I'm going to go ahead and use the master package template for a fact table, and we'll just call it myFact. Normally we would call it the name of the fact table, so we'd say like fact sales, but I already have one that's completed. Go ahead and add this to my solution. Give it a minute to come up here. You'll see that here comes the template all ready to go. We've got a data flow all ready to go. Okay. I do three things before I can start developing. I come over here and take a look at the properties. You can see it's called neuFact, so I'll change it. I'm going to change it to fact sales because we actually use the package name to drive some of the logic. I'm going to go ahead and generate a new GUID for this package because when SSIS does its own natural logging, we want each package to be unique. So I want it to recognize my package as a brand new package it's never seen before. Then if you look over to the left-hand side, I've got a whole bunch of variables listed here. I'll try to show you some of them. A lot of these variables are being set by the accelerator, so you can see that access file path up here at the top. You can see all this information's been read in. And you'll see I've actually queued you up to have you give me the name of the table we're going to load. So we're going to load fact sales. And now I'm ready to start coding. So let me go ahead and I'm going to show you, I'm going to flip over and I'm going to show you some code that we write. What we do with the SSIS process is there's a lot of things you can do in SSIS. We've seen everything from just execute a SQL task, and they call that the ETL process, which is basically just getting back to our traditional ways of just writing stored procedures that just do everything, including load the table. What we've taken is a nice blend of using SQL for what SQL is good at and using SSIS for what SSIS is good at. So what you're going to find is I've got a stored procedure written here that's going to load from my staging environment to my target environment. And you'll notice that I've named the procedure ETL fact sales, which is the name of the table that I'm going to load. And you'll see that in this query, I'm basically querying from my staging database, from this particular staging table. I'm doing all my joins out here, doing a bunch of left outer joins and using -1s if the key's not found. You know, it just depends on your environment. And so I'm incorporating all the extract logic and some of the transform, you know, some of the data conversion logic all in the SQL environment. We love doing it this way because encapsulating in a stored procedure makes it really easy for us to change, and sometimes maintaining it this way is actually better than doing it directly in SSIS. So you'll notice, in terms of the mapping, I'm taking this S order number from the staging table, I'm casting it as a varchar 10, which is my destination data type, and I'm going ahead and naming it my target name right off the bat. And you'll see why I'm doing this here in a minute. It actually streamlines the entire mapping process in SSIS if you do this. I could leave all these aliases off, but what I would end up with is order number, item number, and I really don't want to talk about the store system any longer than I have to. So, you know, I put a store procedure in up front, I map all my data, I do all my data conversions, I do all my joins for the most part, and then I hand this data over to SSIS. So now if we bounce back to Visual Studio, you'll see that I have a complete process ready to do package initialization. There isn't. I'm going to just show you a little bit of this code. I'm going to have to move fairly quick, or I'm going to run out of time. What you're going to find is in each one of these boxes, we've got all the code. Basically, we're passing a whole bunch of parameters from the package itself, and then we're going ahead and initializing the audit table. I'm going through this pretty quick. We're storing some of the results. We're storing the package execution key. If I go look at this guy, You can see we're doing a bunch of work here. Inserting into this table, taking a bunch of parameters, returning the table process key. We're mapping some parameters here. Capturing a result set here. We're getting this audit key. So we're inserting into that audit table and we're getting the key back. And then on this incremental load piece, we're basically doing a query to say, let's pass in the package name. Let's go out to that package load strategy table. In this example, we're using get date. The current system date is the incremental next load date, and we're getting some load information for this load out of that table. And then if we continue down a little further, just want to show you what some of the code looks like. I'll probably just jump to the finished solution so I don't run out of time. I'm in here, got a little coding I need to do. Truncate a couple of staging and error tables, pretty simple to do. Then if we jump over to our staging, we've got a data flow already set up to do the staging piece of it. Come back. You'll see these initial row counts. I don't even need to touch these because basically I'm passing in the target table name and I'm building dynamic SQL on the fly. So I don't even need to come in here. I'm just showing you what it looks like, but I don't need to touch any code here. We're disabling indexes and constraints. Again, this one we come into, there's nothing we need to do here. It basically knows the table name we're passing in. Disabling all the constraints and the indexes for us, doing all the housekeeping so we can do a fast load. We're doing the load process here. Again, there's nothing to do here. All this is being done for me. All I have to do is pass in a target table name. It takes care of the rest. And then on success, we're using our incremental next load date and going ahead and updating that table. So we're going ahead and moving our data forward if we're doing an incremental load. And then down here we've got some final counts. We don't need to go into that. And then we're doing all the wrap up on the package. You look down through here. I'll just take a look at this last one for you. You kind of get the idea. We're setting a stop time, successful indicator. So you can see there's a lot of housekeeping that goes on here. And you'll notice, I'm going to go ahead and bring up the finished product. Literally, I could take a package like this and within 5 or 10 minutes, once I've got the SQL coded up front, I can move very, very quickly through this. So you're going to see here in the data flow, let's take it from the top here. We're going to load staging first, right? So we're going to look at our source data. And I've got a little query here. I want to query from the fact table where the invoice data is greater than or equal to this first parameter I'm passing in, and then I'm checking the load indicator. So basically what I'm saying is if the incremental load indicator is true, I'm going to respect this date and I'm going to incrementally load from this sales table in my source system. If it's false, then I'm going to load the entire table. So you can see with just a couple lines of code, I've basically got a package that can do either incremental loads or full loads very easily. And you can see my source columns coming in here. And then loading it into a staging table. Straightforward mapping, maps itself. All the columns are the same name. We ignore the staging ID, so there's really nothing we have to even do here. Then I'm going to get back to the data flow here. So then on the stage data, we execute our store procedure. Notice the columns as they come in. They look fantastic. They look exactly what I want to load in my target environment because I put in the effort to set it up that way. As far as metadata columns, I'm adding all my metadata columns on the fly. So here's the audit key coming in, being used on an insert and an update. I'm using get date on the created date and modified date, bringing in the package execution key and table process key for later use. Keeping track of how many rows I'm inserting. So I'm storing that in target insert row count. inserting into the fact table, and this is very easy the way that we've done it because we've named all our columns ahead of time. Everything maps perfectly as it should. I actually go ahead and remove the column, the links for modified date and update audit keys, so that's really quick. Then down here, just a sample error metadata process. This is where I actually put in my description. So if I had a failure loading into that table, this particular ETL strategy says, okay, bypass the failure, go ahead and send the records down. We'll go ahead and stamp them with some error information. We'll keep track of an error, insert error count. Don't need to go into this one, you've already seen it. That kind of logic. Then we're loading the sales detail fact error, which is the associated error table with the staging environment. And you'll see everything maps automatically because of the way we've named things. So our staging ID maps, our error IDs, the package execution key, all these things are coming together at the same time now and completing this process. Just a note on some of the connections down here. All these connections are already pre-configured. So you'll see that the source database and the source server are coming from variables. Look at the target database, you'll see the same thing. Target database, target server. And if you look over here, you'll see that my staging database is MFC staging. It's on the local host. The target is MFC. Target server is local host. If I go up to my package configuration, just to show you a little bit more about what's going on, you'll see that I've got two environment variables on this machine that are basically setting the ETL server and the ETL database. So I use two environment variables up front to basically set these variables, and then everything else gets read in from that SQL Server table. And then now that I've got my, you can see there's very little coding that goes on in this thing, and I can then go ahead and load. It takes like a minute. Go ahead and run the process. Try to scroll up to show you a little progress going on here. There's actually 271,000 records in the source table, but I think we're only going to load about 111,000 because that we were just grabbing from 2008 forward. Here we're loading our fact table already. It's done. It was successful. There was no errors reported. Process is now done. Now that I've finished the process, let me go and just take a look at, you'll see in this solution, I have a report that shows me package execution, so I'm going to go ahead and run that report. It's not a real fancy report, but you get the idea. You can see the results of all my packages that have run before. The Accelerator allows me to run child packages as I just did, fact sales, which was just run, or I can run them as part of the master package. When I run them as part of the master package, I've got a little drop down here that shows you, oh, I loaded a dim table, I loaded a fact table, and then I can drill in and see how many records I loaded. But let's take a look at our last load. So we ran for 31 seconds, started, you see the start and stop times. The package ID is 221. We loaded the fact sales table. We extracted 111,000 records. I had emptied the table before we started, so there was nothing in there. We actually inserted that we were planning on inserting 111,824. We didn't do any updates. We didn't have any errors, insert or updates, and our final count is in the table, 111,824. The audit key is 204. If I go and query this table now, top 1,000 on fact sales, you'll see we've got a table loaded now. Looks great. Scroll over to the right-hand side. And then we see we've got a, I think 204 was my audit key. Yeah, it was. Yeah, 204 was the audit key. Audit key's been successfully recorded. Created date's been successfully recorded. We skipped the modified date and the update audit key. And that's the ETL Accelerator in a nutshell. Any questions?
We did have a question come through. To ask a question, please click on the Q&A verbiage located in the toolbar at the top left side of your screen. The question we did have come through was, why is it easier to stage?
Why is it easier to stage the data? Honestly, it actually takes more work, right? There's a lot of folks out there that would say, why do I need to even bother with the staging environment? What value does it provide? I can just get the data, bring it straight into my data warehouse or target environment, and why should I go through another step? The reason why you go through another step is because we would like to bring in the data in its original state into a staging area so that we can actually see the records exactly as they were before we changed them. So it's just common, especially with data warehouses, it's common best practice to actually stage data first before loading it directly into a target environment. And as I mentioned, when you're loading spreadsheets and flat files, you definitely want to do it because if you have a problem with, record 523 on a flat file, it's so much easier to see that in a staging table than it is to go combing through a flat file. If you've provided no stop between the flat file and the target table, you don't have that intermediate area that you can evaluate the data. The other thing to keep in mind as well is that, especially with data warehouses, is that we don't always have access to the source systems and all the source data that they may contain. And so typically we will stage data from the source system. We will keep a persistent copy of that data in staging, and then we'll load it from there. So on a reload, we may not even go back to the source at all, and we'll just load it from our staging area. So that's just another good reason for using a staging area is, when you aren't able to go back to the source system and you do need a place where you can look at the original copy of the data.
Great, thank you. If anyone has any more questions, please feel free to type them in at this time. In the meantime, I'm going to click through a few polling questions, and we would greatly appreciate your feedback. The first question, was this content helpful for your business? Yes or no? Give it a few more seconds. All right, thank you. The second question, please rate the presentation content. Excellent, good, or poor? All right, thank you. And the last question, would you like us to schedule a follow-up? All right, thank you. And we actually had another question come through.
Okay.
Could you elaborate on how you set up the environment variable and map it to your location?
So I'll go ahead and show that to you on my machine. So should go ahead and just share my desktop back here. I'll go ahead and just take over here. So under Control Panel, System, you'll see that for MFC, basically I set a variable that says that the MFC database where the ETL configuration table is stored is in the MFC staging database on localhost. And so by doing this, I can take these two variables, MFC database and MFC server, I can put them on a number of different servers, and I can change this information if I want, but it basically insulates the entire ETL environment from hard-coded paths and so on. And so we found that environment variables work really well. One thing you have to keep in mind about an environment variable is when you set the environment variable, SSIS will recognize what that variable is. If you change the value of that environment variable, you have to actually reboot the machine to actually have SSIS recognize what the value of that new environment variable is.
Great. We had one more that came through. At what stage do you log to stage forecast and stage forecast error?
Okay, so stage forecast is where we're loading from, And I'll go back to the ETL process here. Whoops. Let me share my content. Well, I think I'm. So basically, we're loading from the stage forecast table, and it's at this point right here where we're actually doing the insert. So if I had some failures, basically they would have been redirected down to, I'm not showing this very well. Make this a little smaller. So it's basically at this point, so as the data is coming down through fact sales, I've told it to redirect any records that aren't going to insert correctly, and then I've gone ahead and so they get inserted down here. So we load from stage forecast. If we get any errors, we throw it into stage forecast error.
Great, thank you. If there are no further questions, we would like to thank our presenter for the wonderful presentation. Again, we will be forwarding out the recorded version of this presentation when it becomes available. If you have any further questions about this presentation or Neudesic in general, please feel free to email myself or Alan at the email addresses on the slide, which we'll put up in one moment.
Here, so go here and go to here.
Again, thank you so much, everyone, for joining us today, and we look forward to seeing you on our next webcast. You're now free to disconnect. Thank you.